today. So, yes, first off, give you a heads up of what we have the rest of the way through. Got a worksheet due tomorrow. Do a lab, like tomorrow, the next day, or do a lab quiz at the end of the week. Review worksheet due on Monday. Test Tuesday. Review Wednesday, Thursday, and then we're at finals. Crazy. Okay. So today we're gonna take what you did, what you learned already on this worksheet, but we're gonna incorporate mass times velocity into that. Okay, so momentum is equal to mass times velocity. So, let's say you have a bowling ball that has a mass of 7 kilograms and initially rolling at 2 meters a second to the right. So it's going slow. And the bowling pin has a mass of 4 kilograms initially at rest. Right after they collide, bowling ball is now going at 0.25 meters a second to the left. How fast is the bowling pin going and in which direction? So in this scenario, we've done a slow roller, bowling ball hit the pin, and it caused the bowling ball to bounce back ever so slowly. We'd have to get an attendant because now it's in the gutter and not rolling through. Okay. So first step we're going to do is pick which objects are going to be in the system. Well, we've seen this scenario a lot of times. So bowling ball, bowling pin are in the system. Okay. Step 2 is pick which way you want to be positive. Okay. In this scenario, I would suggest to the right is positive, to the left is negative. Okay. So, to quantify conservation of momentum, you have the momentum of the ball initially plus momentum of the pin initially. So that's the total momentum of the system beforehand. Or adding up all the momentums of the objects in the system is equal to the momentum of the ball afterwards plus the momentum of the pin afterwards. This is the math representing conservation of momentum. It's the math representing conservation of momentum. The total momentum of the system beforehand is equal to the total momentum of the system afterwards. Look at that. Okay. Now, this next thing is probably the most crucial step. Okay. So, momentum is equal to mass times velocity. Okay. Mass doesn't have direction. Velocity does. So whatever the direction of velocity is, that's the same direction as momentum. Okay. If you are given numbers or values for velocity or momentum, then you must assign a positive or negative sign to each number. Okay, that right there is pretty much why 80% of the people would miss a problem, is because they fail to do that step correctly. So if you're given numbers for velocity or momentum, then you must assign a positive or negative sign to them. Okay. Which way is positive, which way is negative, that doesn't really matter. You just, once you assign this, once you define this, you must be faithful all the way through. Okay. So what does that look like? So here, momentum of the ball, we have 7 kilograms times positive 2 meters per second. Okay. Velocity, I gave it a positive sign. Now, obviously, if you don't write the positive sign, you're still going to get it right. Okay. Plus, momentum of the pin was 0, it was at rest. And afterwards, the ball still has a mass of 7 kilograms, but it is now moving at 0.25 meters per second to the left. That right there is captured. Because I have a value with it, I need to assign a positive or negative sign. Failing to put the negative right here is 80% of the reason you would miss that. Okay, and on a multiple choice test, guess what a wrong answer is going to be? Forgetting to put that negative sign. Okay, so plus 4 kilograms times the pin's final velocity. Okay. I was not given a value for this, so I am not going to make this velocity positive or negative. Okay, only if you're given numbers. Do that. Okay, there's the setup. Math is pretty basic. Nope, that's 7.5. .9. Okay, so answer ends up being at 3.94 meters per second. Okay, so it's asking how fast the pin is going and in which direction. The fact that this ended up being positive, my answer is positive, so that means to the right. Okay, is that what we would expect? As the bowling ball hits the pin, which way would you expect the pin to go? Right or left? To the right, so it checks out with what we'd expect. Okay. The last point I want to make with this is, was the velocity of the system conserved? Started with a velocity of 2 meters per second. It ended with a velocity of negative 0.25 and plus 3.94. The velocity is not conserved. The momentum is. The velocity is not. That's a pitfall that I've seen some people fall into. Okay, velocity is not conserved. Good with that. Questions there? that is pretty much the extent of the difficulty of the math of this unit. Okay, this is where you're going to miss it. Okay, all right. This is written instructions on how to bake a momentum problem. I just talked you through it. You're welcome to take a picture if you want, but sound good? Okay, we already talked about this one. Example is no, total velocity is not conserved. Let's look at another example. So you've got a big 5-kilogram fish is swimming at 6 meters per second westward towards an absent-minded, smaller 2-kilogram fish swimming at 3 meters a second eastward. When the 5-kilogram fish swallows the 2-kilogram fish, what is the 5 kilograms fish's velocity immediately after lunch? Okay, so step one, what objects should we put in our system? There are 2 fish. Okay. Step 2, we define which direction to be positive. Okay, now, if I was you doing a homework problem, I would make west positive because I would assume that that's the way it's going to be moving at the end. But to identify or highlight some things, I'm going to make east positive. It's going to work out fine either way, but I want to like highlight something here. Okay, so I'm going to make east the positive direction. I'm going to make west the negative direction. Okay, so I've got the big fish initial plus the momentum of Dory initial. Let's be honest, Dory would not make it past infancy. So finally, big fish finals momentum plus Dory's momentum final. Okay, I want you to do the left side of this equation. I'll give you like 30 seconds. Just set it up. How do we do? Okay, making east positive, big fish is going west, so that needs to be negative. This right here would be the reason why most people would miss this problem. Okay. If you would have made west positive, you would need to make this negative and that positive. I messed that up, didn't I? There you go. Looks better. Okay. Now, for the right side, does Dory have momentum after she gets swallowed relative to you? Does Dory have momentum after she gets swallowed relative to you? Okay. Here's what it would look like if Dory did not have momentum after she gets swallowed relative to you. Just keep swimming, swimming. You follow that? So either Dory busts the tail out of the end of the big fish, like just keep, or the big fish had an amazing digestive tract. Okay. Here's what probably more realistically happened. Just keep swimming. Does Dory have momentum after she gets swallowed relative to you? Yes. She's moving. Her body is moving. How fast? Just as fast as the big fish. Because now in the big fish. You all right with that? So you can set this up like this. You have 5 kilograms times some final velocity plus Dory's body at some final velocity. Or you could think of it like this. You could think of it as in the big fish plus the full belly that the big fish now has with some final velocity. Either way is fine. Good with that? Okay. So that's your setup, and the rest is just math. Okay. So going at 3.43 meters per second. Direction wise is what? This signifies westward. Okay. So a quick recap. Well, I guess before we recap, is this what we would expect? We would expect the big fish to keep moving westward after swallowing. Yeah. Okay. To recap, if you're given a velocity or momentum, you must assign a positive or negative sign to that. If you're not given a value, do not assign a positive or negative sign to that. And that will come out in the answer. You'll know the sign, the direction of that based upon the answer. Good with that? Okay. All right. Revisiting our football players. Tell your neighbor. Correct answer is everybody go to C? Okay, they're moving together. One velocity. Okay. Next question. So this question is considering them as two separate objects moving together. Have a conversation. Correct answer is? Correct answer is D, dangerous dinosaurs. They have the same velocity, but what do you need to know? The mass. You don't know their mass. Okay with that? Okay, so here I've given you some masses. Dr. Niebuhr? Correct answer is A. 200 divided by 80 is greater than 140 divided by, oh, you can't see my, 200 divided by 80 is greater than 140 divided by 100. Good with that? Last question. Correct answer is the one, okay, they both have the same velocity. So the one that has more mass has more momentum. B, Maverick. Good with that? Okay, you got a worksheet due tomorrow.